Really excited to be here, present our evolution. OK, what is EigenLayer? Some of you may have heard of EigenLayer as a restaking protocol, a protocol where you can stake on Ethereum. But today, I'm going to unveil our evolution. So when you think about how application development works in crypto and how application development worked in web applications, let's say back in 1995, if you were building a web application, you have to build your own server. You have to build your own identity stack. You have to build your own payment stack. You have to build your own databases. You have to do all of these things. In 2025, if you're building a web application, you absolutely don't do any of those things. You go use a public cloud like the Amazon Web Services. You go use a software as a service like Okta, like MongoDB, like Stripe, like PayPal to fulfill each one of your utilities. So when you think about the cloud, what did cloud do? Cloud made it possible to build web servers really easy, to make it possible to build web applications really easy. The goal of EigenLayer as the verifiable cloud, what does verifiable mean? All of the crypto economy is differentiated, and we think of it normally as, oh, it's decentralized. But really, the fundamental value proposition is that crypto is the verifiable economy. When you operate with Bitcoin, you know you have there are only 21 million coins. You know you own your coin. That's what it means by the verifiable economy. And we think of EigenLayer as this verifiable cloud. So what does it enable? It enables you to build new decentralized protocols really easily. If you were to build a decentralized protocol in the absence of EigenLayer, what you have to do is you have to go find your own community. You have to find your own, issue your own token, have them stake that token, find a group of operators who then opt in and run that protocol, and build the whole stack to build a layer one. What we do with EigenLayer is let you build specific, useful, productive services on top of a common framework. So that's what EigenLayer enables. That's why we think of this as the verifiable cloud. If you want to build a decentralized protocol, just like the cloud, you can write a code and ship it to the cloud and make it run everything on the cloud. With EigenLayer, you can write a decentralized protocol, just upload it to EigenLayer, and there is a group of stakers, operators who pick it up and run it for you. So cloud provided the physical infra. EigenLayer provides the verifiability and the trust infra for anybody to build new and interesting decentralized services. In Amazon, the public cloud, they're called Amazon Web Services. In EigenLayer, we call them autonomous verifiable services. Autonomous because they run on their own. What do you mean they run on their own? They're permissionless for anybody to stake and keep these services running. So they run on their own. They're verifiable. If you don't run the service correctly, then they will be penalized on EigenLayer. So the underlying infra is in a cloud, it's data centers. In EigenLayer, it is stakers and operators who actually stake and run the system. So what is the state of the union? Where are we today? On stake, EigenLayer invented this concept called restaking, which is, if you're staked in Ethereum, you should be able to participate in EigenLayer and provide services to a variety of other protocols. Here is our curve for TVL, and you'd see it's oscillating around 4 to 5 million ETH. Depending on ETH price, 8 billion today, it fluctuates. Operators. We have operators all over the spectrum, from home stakers and operators to crypto giants like Coinbase, to Web2 giants like Google Cloud running first-party operators on EigenLayer. So you have nodes which can come and service any protocol you want on top of EigenLayer. OK, what is happening with all this stuff? You have the stakers and operators. Many people know of us only as restaking or staking. But staking is just an input to produce some outputs. The outputs are new, powerful, expressive services. So that's what AVSs are, autonomous verifiable services. These services that anybody can build on top of EigenLayer. And so today, we have 40+ of these services on mainnet, 100+ on testnet. So when you think about each one of these services, they're as complex as a new layer 1 blockchain, a new different kind of layer 1 blockchain, because each of them don't do the same thing. They're not all just ordering transactions and giving you like a blockchain. They do very unique new things. Each one of these services, really, really hard to build, but hundreds of them are getting built today. Something we did not expect when we got started. And the category of AVSs spans from lots of homegrown breakthrough innovations to giants like Infura, which is the leading RPC provider, building a decentralized infrastructure network on EigenLayer, to Layer 0, the leading bridge, building on EigenLayer. So just some examples there, but we have a lot of adoption on this category of autonomous verifiable services. And this was a category map. Like, what are these services? This was a category map we created saying, oh, you can create services like a sequencer or bridge or MEV monitoring or AI inference, run a Linux box, prove that your location is correct, prove that you're running inside a cryptographically encrypted enclave. All these very complex cryptographic services all running in EigenLayer. The Electric Capital Developer Report rated us as the top growing ecosystem, developer ecosystem in crypto. OK, so this is what's happening. A lot of this stuff is, we got the stakers, we got the operators, we have these powerful services. Now, but for most people, for many of you here, this will come as a surprise. Like, I thought EigenLayer is not doing anything. And the reason is, it's all underground. What do I mean by underground? When I'm a user and I come into a blockchain, I don't see all the infrastructure services and stuff. They're all like underground. What I see is I interact as a user with applications. That's what most users do. They interact with applications. And applications is at this, is what is accessible. And under the ground, we've built all this complex infrastructure. So we are now evolving from focusing on these underlying pieces of how do I get stakers, how do I get operators, how do I get services, to actually thinking about what are these new applications. How do we empower this new grade of applications that is simply not possible in the absence of these powerful services? So that's where we are going. In EigenLayer is a very exciting evolution for us, because EigenLayer itself is a very complex, multi-sided marketplace. You have stakers, you have operators, you have services, now you have apps. And so we're just moving forward into this direction. So let me just give you like an analogy to peg you to like what this thing looks like. When you look at a public cloud, like the Amazon Web Services, what's happening is underneath everything, there's shared infrastructure, data centers, which power the cloud. And on top of the data centers, Amazon has built, AWS has built some very powerful services. EC2 is a computation service. S3 is a storage service. DynamoDB is a processing service. There are all these different kinds of services that are built on top of AWS. AWS built some of these services themselves. On top of these services, other people built lots and lots of third-party services. Major companies built on top, like Snowflake, worth maybe $100 billion. So you have this category of third-party services built on top of AWS, and then applications like Uber, Netflix, everything built on top. And so what we are trying to do at Eigen is to create an equivalent of the cloud on verifiable premise. So the idea is at the base layer of EigenLayer, at the base layer of the verifiable cloud is EigenLayer, which is shared infrastructure, right? So shared infrastructure for what? For staking, operating. But we're not just building EigenLayer, which is just this one piece. We're building all kinds of powerful primitives on top. EigenDA is a data availability service that's built on top. What is a data availability service? When you want to write data into a blockchain, you want to publish it so that anybody can access it. And EigenDA is the highest throughput data service available in all of blockchains. So 6 months back, we did an experiment where we crawled all the blockchains that exist, including Bitcoin, Ethereum, Solana, everything else, and wrote the data to EigenDA. And when we write it to EigenDA, there is still 50% more space left. That's how much throughput EigenDA has. So we have some really powerful new blockchains being built on top of EigenDA. Mega ETH is one example of a blockchain that you may have heard of. but many, many powerful unlocks coming up once you scale the underlying infrastructure. So EigenLayer is a first-party service. We are now building other more powerful services that go along with it. Not going to be talking about them. But on top of these services, we have these AVSs, which actually build third-party services, which anybody else can then use. And then on top of this, we have applications. And applications which can then take these and then build powerful, useful things. I'll just highlight one application today. On the left, you see Earnify. Earnify is the top paid finance application in the App Store. It's the top paid finance app in the App Store. If you go and look at it, you wouldn't know it's a crypto application. You just think it's a regular application. What it does is it's a payroll loan. When you go to your, imagine I'm working at the Cheesecake Factory and I want to take a loan against my payroll. And how do I prove to the lender that I actually am solvent, that I actually receive this $4,000, $5,000 a month in my account, and I just want to borrow against that? How do you prove to a counterparty this kind of a fact? You could log into your Cheesecake Factory employee login and then show to the blockchain that you are actually a bona fide employee and you've received your previous pay stubs. All of these things can be validated. But to validate this, the layer that actually helps us do this is a service built on EigenLayer called Opacity. Opacity is a zk-TLS network. It's a complicated acronym. But what it does is it lets you prove, as a user of any system, what is the information under your login. Imagine I can log into my bank and then prove to the blockchain that I have a certain bank balance. I can prove to a blockchain that I have a certain driver rating on Uber. I can prove to a bank that I have a social security number, and I'm a unique person. All of these things can be proven using this one layer called Opacity. And the level of expressivity and innovation that we're going to see because of these foundational unlocks is mind-boggling. We're just getting started. OK, so how do we contextualize this in terms of everything else that's happening in crypto? You think of these two axes. One axis is verifiability. Blockchains are built to be verifiable. Right? So they're very, very verifiable. So you see this on the top. They're highly verifiable because anybody can download and run the blockchain and verify that it runs correctly. But is it expressive? What do I mean by expressive? What sets of programs and logic can you express inside of blockchains? It's very limited. Today, it's mostly financial transactions. I send you money. That's the level. Or you say, like, oh, is this guy collateralized enough? And this kind of simple foundational logic is executed very robustly on top of blockchains. But what we want to do is anything that you can program today in a web application on top of the public cloud, you should be able to just simply do this on top of blockchains. And that's our goal, is to make crypto highly expressive, highly powerful, so that when you build an application, any logic that you can express on the cloud, you can express inside a blockchain. Or you can take the cloud and say that, hey, I'm going to make the entire cloud verifiable. So that's what we're aspiring to at Eigen. And so what this does, how does it fit in with the rest of what we've been doing? Till now, we've been focused on the first part of this flywheel called the shared security flywheel. The more security that is there on EigenLayer, the more AVSs want to build. The more AVSs that are built on EigenLayer, the more fees that exist, and therefore the more security comes. But what we're doing is moving from security as the main thing that is built on EigenLayer to the main thing that's built on EigenLayer is shared distribution. We want to create a flywheel where applications use Eigen to integrate with all these powerful services. So we're building a lot of powerful tooling for application developers to come and mix and match these services. Hey, I want to use this storage service. I want to use this AI inference service. I want to use this authentication service. And you can mix and match them to build very powerful apps. So here is a picture of what might be these powerful apps. What are the categories? These are just like a small smattering of examples. Already I talked about Earnify, so let me talk about medical insurance as an example. When you think about what is the scope of blockchains, most people, like I said, think about blockchains as being able to do transactions correctly. But think of medical insurance. A the fundamental thing this blockchain offer is this new trust paradigm, right? So recently, we had an unfortunate episode with the United Healthcare where, people are really frustrated with how medical insurance claims are adjudicated. And what you do normally is you say, like, hey, this company is adjudicating the claims. Instead of trusting a company, and there is very little trust in these companies today, instead of trusting a company, what if you could take an AI protocol and put it on top of a blockchain? Whenever you submit a claim, an AI protocol adjudicates and administers your claims. To do this, you need to be able to run AI inference inside a blockchain, just like you're running smart contracts. And this is not possible today in any blockchain. So when people say, oh, this blockchain has more throughput than the other blockchain, they're all still talking about transactions per second. It's financial transactions. But what you need, the level of logic you need to express an AI inference on-chain is completely different. Just doesn't exist today. And this is what we are trying to solve at Eigen, is to give this superpower to any blockchain, any application can now integrate with Eigen and then be able to bring inference on-chain, bring privacy on-chain, bring randomness on-chain, have compliance filters, have AI filtering for transactions, all kinds of things. One particular category we are very excited about in this large scope of what kinds of applications can be built on top is AI and AI agents. And so when you think about an AI agent, today what most of the AI agents in the crypto land look like is, hey, here is an agent. It holds a wallet, a crypto wallet. That's what they look like. And they're mostly highly centralized. Not mostly, pretty much all of them are centralized. There's a single node, which basically is an agent, and then it interacts with the chain. This is not very different from giving an AI agent a Stripe API or a PayPal API. They can, you can just do the same thing with existing Web2 Rails. So we don't find this interesting or unique in terms of what blockchains can do. They're fully centralized, they're not unstoppable, they're not verifiable, so the relative value proposition of these agents is very small. But our vision for what verifiable agents look like is very different. How different is it? Imagine you can take a smart contract. A really cool thing about a smart contract is it's a piece of code that owns a piece of property. It owns a digital asset. So that's what a smart contract is. Imagine you can take an AI agent and then just put it inside a smart contract. Today, you can't do it. None of the blockchains, this is possible. You can't take an AI agent and put it on top of a blockchain. And if you can't do it at this grade of verifiability and security, nobody is going to trust these agents with their money and TVL. So that's the superpower of what is possible. But it is not practical. There's no blockchain in which you can do it today. EigenLayer makes verifiable agents practical. Not just possible, but practical. Because what you can do is you can actually build a smart contract on top of a blockchain and tether it with an Eigen AVS. So what this AVS does is it brings verifiable inference. Nodes run this inference, they stake money, they promise that they're running it correctly, and they're adjudicated back on chain. And once this inference runs, you can take that result and then bring it back to actually make on-chain actions. This makes these agents as powerful, as verifiable as a smart contract. So this is a new paradigm shift in what blockchains can be capable of. And when you think about AI agents, it's not just inference. It's a broad category of all kinds of things that are needed. An AI agent needs inference, training, data, GPU markets, internet oracles. All of these exist as services on Eigen. So you can actually build very powerful, full supply chain verified AI agents on EigenLayer. Finally, bringing AI on-chain not just it also accelerates the foundations of how crypto works. When you think about how you sign a transaction, how DeFi works, how governance works, all of these things can be massively accelerated using AI on-chain. So with that, I'll stop with a call for developers. Come build highly expressive crypto apps on Eigen, verifiable agents, and make smart contracts smarter. Thank you so much.